Good morning, students. So the sixth lesson we have completed. So far 6 lessons completed. Today 7th lesson, heat. So, lesson chapter 7, heat. So already we have learned heat from 6th to 8th standard. You have learned now can you say what is heat? Heat is a form of energy. It is a form of energy. Heat is a form of energy. Now we are using in our daily life heat. So if you carefully handle heat means it's useful. But careless if you handle it gets damaged. That everyone knows. So the heat very important to us. And when we are heating, some effects also there. So that effect now we can learn. So suppose a beaker. If you want to heat your water, what happens? We are taking some utensil and fill water and we are giving heat. We are giving heat. Now the water, some changes takes place. Temperature will change. So suppose 10 degrees Celsius. First it will change 10 degree. Next 20 degree, 30 degree, 40 degree, 50 degree. At last it reach a boiling point. So here what is the change in temperature? So first effects of heat. First one, change in temperature. First effects, what is that? Change in temperature. Second one, change of state. You know change of state. What are the 3 states of matter? Solid, liquid and gas. There are 3 states of matter. First ice. For example, for solid ice. When we are heat this ice cube, what happens? It becomes liquid. Further, we are giving heat, what happens? It becomes gaseous state. So, by the effects of heat, it changes the change of state. So, second one, what is that? Change of state. So, first one, change in temperature. Second one, change of state. Third one, expansion. When we heat, some pipes are there. When we are heating, what happens? It gets expand. Water also, when we heat, it gets expand. So, that's the expansion. Expansion. Then, fourth one, chemical energy. Chemical energy. So we learn heat is a form of energy we have learned. So here when we are giving heat, suppose when we are cook food. So first water and rice is there. Some reaction will take place after that will we get to food. Okay, to cook food. So that will chemical energy. So these when we are giving heat, some effects are there. So these are the effects of heat. First one, change in temperature, change of state, expansion, chemical energy. Can you understand, students? What are the effects of heat? Now next, which way the heat will transfer? You can see. There are 3 ways for the heat transfer, or in 3 ways. The first one is convection. Conduction. First one is conduction. Second one, convection. Third one, radiation. So the heat transfer into 3 ways. What are the 3 ways? Conduction, convection and radiation. So conduction will take place in solid. In solids. Conduction will take place in solid. Convection takes place in fluid. Fluid means liquid. Okay. And the radiation takes place like the electromagnetic, in the form of electromagnetic waves. Okay. So conduction takes place in solid, convection takes place in fluid, and the radiation takes place like electromagnetic waves. So first we can learn about conduction. So what is one example for conduction? When we are cooking food as a fuel user, we are cooking food. What will happen? We will keep wood. So one end of the wood only conduct heat. After some time, it transfer from the higher temperature region to lower temperature region. Okay. After that, after some time, it changes from higher temperature region to lower temperature region without the actual movement of molecules. Without the actual movement of molecules, that only conduction. See, the heat transfer from the higher temperature region to lower temperature region without the actual movement of the molecules. That's only what is that? Conduction. Now see the convection. Convection I told occurs in fluid. Fluid only it occurs. No? So the convection means the heat conversion is a process. The heat transfer from the higher place temperature to the lower place temperature. That's only with the actual movement of fluid. Fluid itself only it happens. But here without the actual movement of molecule, here with the actual movement of fluid itself. Okay, convection. Radiation means the heat transfer from one place to another in the form of electromagnetic waves. So the heat transfer into three ways: conduction, convection and radiation. Now we can see some diagram about the conduction. See the picture. Look at the picture of the conduction. Look at the picture. The heat transfer into three ways: conduction, convection and radiation. First see the picture for conduction. So conduction, see this the wood. One end we are giving heat. So after some time the heat transfer from the higher region to the lower region of the object. Okay. First the heat is given in one end of the wood. After some time the heat transfer from higher region of temperature to lower region of temperature. So this is the conduction. Now next one is the convection. This is the conduction. First I explain now conduction. Second one is the convection. See the convection. See the diagram of convection. The convection will takes place in the higher places of temperature to lower place of temperature. The conversion will take place. So the define conversion. The conversion is a flow of heat, the fluid from the places of higher temperature to the places of lower temperature of the fluid itself. That's only convection. Now radiation, this is the radiation. From the sun we will get to radiation. No. So the radiation, the heat transfer from one place to another in the form of electromagnetic waves. So this is the radiation. Radiation means what? The heat transfer from one place to another in the form of electromagnetic waves. So what are the three ways to transfer heat? Conduction, convection and radiation. What are the three ways? Conduction, conversion and radiation. Next one we can learn about the convection in daily life. What is conversion? You know, conversion in daily life we can see. Look at the picture of this convection. See the beaker consists of water. No, when we are giving heat, the heat flowing from the places of one place of the higher temperature places to the lower temperature by the movement of fluid itself. The fluid itself only movement is there when the conversion takes place. Okay. So the conversion is the flow of heat through a fluid from the places of higher temperature region, here only higher temperature region, to the lower temperature by the movement of fluid itself. So next we can see the convection in daily life. Now look at this picture, conversion daily life. First one, hot air balloons. What is this? So many hot air balloons are there, no? So this name hot air balloons. Now the air molecules at the bottom of, here bottom is there, no? Here also bottom is there. So the air molecules at the bottom of the balloon gets heated by a heat source and rise. Here it gets heated, a heat source and rise. As the warm air rises, the cold air is pushed downward as it is heated. The warm air rises, the cool air what happens? Pushed down and it is heated. When the hot air is trapped inside the balloon, it rises. So like that only the hot air balloon rises. Okay. Once again, the air molecules at the bottom gets heated by a heat source and rise. As the warm air rises, the cold air is pushed downward and it also heated. When the hot air is trapped inside the balloon, it rises. Look at this picture for breezes. Breezes, there are two types. One is the sea breeze and land breeze. Now we can see about the sea breeze. During the daytime, the air in contact with the land. Now the air in contact with the land becomes hot and rises. Now the cool air over the surface of the sea replaces, it is called sea breeze. So now see the sea breeze. During the daytime, what happens? The air in contact with the land becomes hot and rises up. Now the cool air over the surface of the sea replaces, it is called sea breeze. Next one we can see land breeze. Look at this picture of land breeze. During the night time, air above the sea is warmer. Where the sea above the air is warmer. As the warmer air over the surface of the sea rises, cooler air above the land moves towards the sea. It is called land breeze. So we have learned, so far we have learned breeze. There are two types of breeze. One is the land breeze and sea breeze. So the sea breeze, during the daytime, what happened? Air in contact with land becomes very hot and rises. Now the cool air over the surface of the sea replaces it. It is called sea breeze. During the night time, air above the sea is warmer. As the warmer air over the surface of the sea rises, cooler air above the land moves towards the sea. It is called land breeze. Yes, convection in daily life. First we have learned about hot air balloons. No, hot air balloons. Second one, breezes. What are the two types of breezes? Land breeze and sea breeze. No. Then third one is wind. The wind will flow. Third one, wind. Wind will flow the higher pressure region to lower pressure region. Okay. Here the wind will flow higher pressure region to lower pressure region. Then fourth one, chimneys. Chimneys are the kitchen, above chimneys are there, you all know. For what purpose? There are some industries also, chimneys are there. What purpose they are using? The hot air gases will come up. For that only we are using chimneys. Okay. So these are the conversions in daily life. What are they? Hot air balloons, breezes, wind and chimneys. So we have learned conduction and conversion also we have learned. No? The next one is we have learned about radiation. So what is radiation? The heat transfer from one place to another in the form of electromagnetic waves. The heat transfer from one place to another in the form of electromagnetic waves. This is only radiation. So far we have learned the heat transfer into three. Now what are they? Conduction, convection and radiation. Definition very very important. What is conduction? What is conduction? The process of heat transfer from the higher temperature region to lower temperature region. Okay, the conduction takes place in solids only. The higher temperature region to lower temperature region without any actual movement of molecules is called conduction. Next, convection. Convection takes place the higher place temperature to the lower temperature in the fluid itself, with the actual movement of molecules in the fluid itself. Radiation, the radiation also one of the heat transfer. It transfer from one place to another in the form of electromagnetic waves. Okay, so these are the heat transfer. The next one we can see the different scales of temperature. Different scales of temperature. What are the scales of them? First one, Fahrenheit. Second one, Kelvin. Third one, Celsius. What are the three scales? Fahrenheit, Kelvin and Celsius. Now we can see the picture of the three different scales. Okay, these three scales also used to measure the temperature. Okay, these three scales also used to measure the temperature. But the melting point and boiling point, freezing point, boiling point different. Three scales also different. Fahrenheit, F, degree Fahrenheit. So Kelvin, No need to put degree, only Kelvin. Degree Celsius, degree Celsius. Like that we can mention. Okay. So here see Fahrenheit, Kelvin and Celsius. What are the different scales used to find temperature? What are the different scales? Fahrenheit, Kelvin, Celsius. Kelvin alone does not means that degree. But the Fahrenheit and Celsius will mention degree. Okay. Now we can see the picture of the. So look at this picture, Fahrenheit scale, that is degree Fahrenheit, given in degree Fahrenheit. This is the freezing point, that is 32 degree Fahrenheit. This is the boiling point, that is 212 degree Fahrenheit. So in between, how many intervals divided into 180 parts, 32 to 212. That's the freezing point of Fahrenheit scale. What is that? 32 degree Fahrenheit. And the boiling point of Fahrenheit scale is 212 degree Fahrenheit. And the interval has been divided into how many parts? 180 parts. Can you understand, students? This is the Fahrenheit scale. The freezing point of Fahrenheit is 32 degree Fahrenheit. Boiling point of Fahrenheit is 212 degree Fahrenheit. And in between 32 and 212, how many divisions are there? 180 parts are there. See here the centigrade scale, Celsius, that is degree Celsius. 0 degree Celsius, 100 degree Celsius. Now here the freezing point is 0 degree Celsius and the boiling point is 100 degree Celsius. So the Celsius scale is called centigrade scale also we can say. Celsius scale is called what? Centigrade scale. The freezing point of the Celsius scale is, what is that? 0 degree Celsius. Boiling point of Celsius scale is 100 degree Celsius. And the interval in between 0 to 100, how many parts are there? 100 parts are there. The formula also there to convert Celsius into Fahrenheit and the Fahrenheit to Celsius. The formula is there. After that I will explain on the blackboard. Okay. So now you have know here Celsius scale is otherwise called what? Centigrade scale. The freezing point of Celsius scale is 0 degree Celsius and the boiling point of Celsius scale is 100 degree Celsius. In between the melting point and freezing point and the boiling point, how many parts are there? 100 parts are there. Next one, Kelvin scale. So Kelvin scale they are given 0 to 273. So the Kelvin scale is also known as absolute scale. Another name what? Absolute scale. Celsius scale, centigrade. Kelvin scale is also known as absolute scale. Here the Kelvin, so 0 Kelvin is there, no? 0 Kelvin represent absolute 0. 0 Kelvin represent what? Absolute 0. The temperature at which the molecule of a substance have their own possible energy. Here the solid, liquid and gases we can measure by using the Kelvin scale. So Kelvin scale is also known as what? Absolute scale. The Kelvin, the 0 Kelvin represent, what is that? Absolute 0. And here 273. 73 Kelvin. Here no need to mention degree. Only Kelvin only we have to mention. So Kelvin is defined as 1 by 273.316 of the triple point of temperature. Here also formula is there. By using the formula, I will explain now. 3 formulas are there. Celsius or Celsius to convert to Fahrenheit and Fahrenheit convert to Celsius and Celsius to Kelvin and Kelvin to Celsius. Now I will explain the blackboard. Learn about different scales of temperature. What are the different scales? Fahrenheit, then Celsius, then Kelvin. Now here some formulas are there. See the Fahrenheit, here the Celsius change into Fahrenheit. Here the formula is F equal to 9 by 5 Siemens or Celsius centigrade plus 32. By using this formula, we have to convert Celsius into Fahrenheit. Suppose the Celsius is given 25 degrees Celsius is given. Just imagine 25 degrees Celsius is given. So you have to write this formula F equal to 9 by 5 into 25 plus 32. So just we can divide now. So here 5 5s are 20, 9 5s are 45 plus 32. Just you have to add 45 plus 32. What's the value? 77. So Fahrenheit, what's the value? 77 degree Fahrenheit. So like this we can change the Celsius into Fahrenheit. What's the formula? F equal to 9 by 5 C plus 32. The next one, Celsius, Fahrenheit to Celsius. For that formula, C equal to 5 by 9 into F minus 32. F means what? Fahrenheit scale. No. Suppose here 35 is given. Fahrenheit given 35. So what we will do? First C equal to 5 by 9 into 35 minus 32. First you have to subtract this inside the bracket first one. So you will get a 3. So here we will get a 5 by 9 into 3. Just you can cancel 3. What's the value? 5 by 3. Just to divide it, you can write the value. Okay? Like that you will get. This is a formula. What's the formula? C equal to 5 by 9 into F minus 32. Next Kelvin, Celsius to Kelvin. So K equal to C plus, C means what? Celsius scale plus 273.15. Just you have to add. Suppose here 25 is given. Just imagine K equal to C centigrade 25 degrees Celsius given. So 25 plus 273.25. Just you have to add 273, 25 you have to add. So what's the value? 8. Here 0.15. Like this you have to add 273, 25. So here 8, 9. So 298.15. Like that you write. Okay. So this is the value of the Kelvin scale. So 3 formulas are there. Fahrenheit F equal to 9 by 5 C plus 32. Next C equal to 5 by 9 into F minus 32. Next K equal to C plus 273.15. So these are the 3 formulas to calculate. For you example problem also there. Just everything work out in the book. Just go through and find out by using this formula. Okay. 3 formulas. What are the formula? F equal to 9 by 5 C plus 32. And C equal to 5 by 9 into F minus 32 and K equal to C plus 273.5. So then so far we have learned this heat lesson. What are the effects of heat we have done. No. The next is how the heat transfer into 3 ways. What are the 3 ways? Conduction, convection and radiation. Now next the different scales used to find temperature. What are the scales? Fahrenheit, Kelvin and Celsius. Okay, by using the scale, here the Kelvin scale is also known as which scale? Absolute zero. And Celsius scale is also known as centigrade. That's all you know. And by using this formula, you have to find it. Okay. Now we can mark the questions. Take your book all of you. Choose the correct answer. Roman letter 1. First question. Calorie is the unit of heat. A option. SI unit of temperature is Kelvin. Option D. Sure. Third question. 2 cylindrical rods of same height have the area of cross section in the ratio 2:1. If both the rods are made up of some material, which of them conduct heat faster? That is rod 1. Next question. In which mode of transfer of heat, molecules passes on heat energy to neighboring molecules without actually moving from their positions? That is conduction. A device in which the loss of heat due to conduction, convection, radiation is minimized in thermos flask. Fill in the blanks. The fastest mode of heat transfer is radiation. During daytime, air blows from first sea to land. Then liquids and gases are generally bad conductors of heat. The fixed temperature at which matter changes state from solid to liquid is called melting point. First assertion reason, first one A and second one B, third one C. Next Roman letter 4, question number 1, define conduction. Page number 81, the process of transfer of heat in which from a region of higher temperature to a region of lower temperature without the actual movement of molecules is called conduction. Question number 4, differentiate convection and radiation. Page number 82, Convection is the flow of heat through a fluid from places of higher temperature, places of lower temperature by movement of the fluid itself. This first point. Radiation, first point, radiation is the flow of heat from one place to another by means of electromagnetic waves. Differentiate, draw the table column and write this one point. Roman letter 5, first one, explain conversion in daily life. Page number 82, conversion in daily life, hot air balloons. Air molecules at the bottom of the balloon gets heated by a heat source and rise. As the warm air rises, cold air is pushed downward and it also heated. When the hot air is trapped inside the balloon, it rises. Side heading greases. During daytime, the air in contact with the land becomes hot and rises. Now the cool air over the surface of the sea replaces it. It is called sea breeze. During night time, air above the sea is warmer. As the warmer air over the surface of the sea rises, cooler air above the land moves towards the sea is called land breeze. Next, winds. Air flow from area of high pressure the region of area of low pressure. The warm air molecules overheat over hot surface rise and create low pressure. So cooler air with high pressure flows towards low pressure area. This causes wind flow. Next, chimneys. Tall chimneys are kept in the kitchen and industrial furnace as the hot gases and smoke or lighter rise up into the atmosphere. This much. Repeat. Students, some questions we have marked, just you have learned. Define conduction, convection, radiation. That question learn well and just write us segment. And this what are the different scales, just you have to know, and formula also you should learn. Thank you.